So that's the first timestamp we'll be collecting. And at step 3, at this moment, PE1 install the routes and start forwarding traffic, right? So, and step 3, PE2 will be watching the incoming packet, eventually receive the packet toward VPN route A at dot transmit data time. So by definitions, the rip-in convergence time equal dot transmit data time minus receive route time. Right. So that's the essence of this test. And here's the test results we have collected. And with this test methodology, right, we can repeat this test in multiple iterations. So in rendified time, we got a pretty consistent test results, around 276 milliseconds with only 15-second deviations. And the second test we ran is a rip-out convergence. So with this test, has the same configuration, 2 test ports. And the objective of this test is to measure the convergence time taken to receive, install, and advertise a VPN routes, in this case using eBGP on the other side. So the test step starts with PE2, advertise VPN routes, and the DUT receive the route annual RI updates at receive route time. And step 2, after some moment of time, PE1 will forward VPN route A to the next peer toward CE1 at dot transmit route time. And by definitions, rip-out convergence equal DUT transmit route time minus DUT receive route time. Right. And here's the test results. We also ran it with multiple iterations and with the very consistent results. The average around 160.6 milliseconds. So with this, consistent and accurate results and the same methodology, we can use the same methodology to evaluate different types of hardware platform, and even within the BGP, I can use that to evaluate the performance of different address family. This could be unicast versus multicast, IPv4 versus IPv6. And the result I'm showing here is the VPN IPv4 routes versus IPv4 routes, right? And in 2 different test categories, rip-in convergence and rip-out convergence. So the key point is you can use this benchmark test methodology to compare convergence performance of different BGP address family and with the repeatable and consistent results. And the last test I want to share with you is the path attributes change convergence time. Right? This one has the configuration require 3 test ports. I have my test port 1 still emulate the CE router, and I have test port 2 emulate a remote PE and also remote VPN sites, and test port 3 also emulate remote PE and remote VPN sites. But behind port 2 and port 3, however, they advertise the same reachability to remote VPN network, VPN route A, with the different attributes. Right? So the objective of this test is to measure the convergence time taken by an implementation to service and BGP path attribute change. Right? So the test step will start with PE3 advertise VPN route A. In this case, PE3 is the optimal path. And CE1 starts sending traffic toward VPN route A. So I would expect the traffic will arrive at the PE3. Right? And then we use PE2 to advertise the same VPN route A, however, with the much better attributes. Right? This could be shorter AS, could be better local preferences, could be, a different variation you could choose from. And the next step, since this one has a better attributes, so the traffic is going to be switched over toward PE2. So PE2 start receiving traffic at the path switch time. And by definition, the convergence time equal path switch time minus path change event time. And here's the test result at the left table. We average out 257.3 milliseconds. And with this same test, we can repeat multiple times. We can repeat with different number of subnet advertised routes, 1,000, 5,000, and 10,000. We can also repeat the same test methodology with different label stack, right? I started with 2 label stack, and we changed it to 1 label stack by forcing set DUT as a PHP router to pop out the outer label before we forward to the test ports. So we can easily evaluate the impact of attribute change on convergence performance, with different label stack and also with different, number of routes distributions. Right? So that make this test very effective. I think last week I previewed this test results with one of the major carrier in US, and this is a very close Ixia customers. And I think as soon as I finished the discussion with them, they immediately took over all my, all the convergence scripts that we have written for these presentations. And obviously, this is kind of a thing they do every day, but it's a very tedious manual process. In order to do this repeatable test with multiple iterations and cover different scenarios, it's always a challenge for a service provider to be able to get the accurate and repeatable test results. Okay, so here's my summary slides. BGP benchmark benefit. I think benchmark test is vendor agnostic, and it's very important. You can use that to characterize the impact of BGP convergence on different types of services, including end-to-end MPLS services using 3107, or even layer 2, layer 3 MPLS VPN based on BGP. And you can use that to compare different platforms across different software releases. Especially when you fully automate it, it becomes a regressions, for carrier, for NEMs, to make sure their design is meeting the performance target and specifications. And you can use that to easily identify the limitation of modern routers. It can help the service provider, the network planner, to better plan their network capacity and expansions. And lastly, it's an important tool, important test methodology to help the service provider identify and understand the problem area and provide estimation of failure of recovery and reconvergence. It's very important how quickly your network is going to recover. Once you have you have that kind of knowledge, you can much better to plan a plan to recover, right? So, and it's a very important metrics. A good test methodology and good test tool can provide you, right? So that's the end of my presentations. All right, thank you. Oh, actually, before I end, I got one thing I'd like to thank you, because since it's been a long presentation since this morning. I have actually I have a gift. I have a gift for you guys. This is a mini iPad. Right? I only have one, and there's so many of you. I cannot give it to everybody.
But there was one chair.
And you included too. So if you guys like to drop by Ixia booth and drop in your business card, or just write down your name and email address, we'll do a drawing by 12:30 tomorrow. make sure you come by and collect your mini iPad. Just want to thank you for attending the session.
Wow. Yeah, so thank you, Dean. Regardless of the present that you promised to one of us, I think it was a very interesting presentation, and we would like to thank you. Is there any question to Dean? Yeah, we have a few questions, so please.
Hi. Although you said this vendor agnostic test, were you able to detect reasonable differences between the boxes that you tested for these BGP convergence tests? Even if you don't want to share the results, but were different values detectable, and would it be important between vendors?
Okay. Yeah, I think that's a good question. Even though I said vendor agnostic, I think that what it means is from a testing perspective, it's going to be the same test methodology, same measurement against, any type of devices. So we treat the device under test as a black box. And in terms of test results, yes, we have conducted this test against different types of router, from an enterprise class to a carrier class, from different vendors, and you do see a big variance between how the router is designed for, what is their function in the network, right? So you tend to see a carrier class router has, of course, has a much better performance, and also depends on how they do the some of the router vendor, they have some special secret sauce, special design to allow the router to converge even faster than the control plane, right? So that's why these BGP drafts try to cover all the scenario and create a common test methodology and something people can use as a reference. I think today, if somebody say, I do this convergence test, I have these results, and everybody will be questioning, how do you do the test? Everybody has a different way to do testing, from using the stopwatch to using a very precise test tool, and to somebody even just set up a router and look at the COI and look at the statistic and log and to determine convergence. So the purpose of the BMWG benchmark effort is try to create a reference tool, reference methodology, so vendor can actually use it and has a good starting point to compare apple with apple.
Okay, thank you.
Hello. Hello.
Hi.
I have two questions actually. For the in and rebound convergence, does not the benchmark include testing several routes?
Sorry, could you repeat that? I don't quite follow you.
Yes, for the in and rebound convergence, you say that you test the time to install one VPN route. Do you not test several VPN routes, like 1K routes or?
Okay, so actually the tests, I think the description is kind of misleading. I think the test we did is based on 1,000 /32 routes, and each route has a unique next hop address, and the test could be you can repeat the test with different size of a network or different type of attributes, and that is something usually you want to exercise. And also in the BMWG BGP draft, it is actually recommended for for the test engineer to try a different kind of combinations and publish those parameters as part of the test report.
Okay, this answers also my second question. Thank you.
Thank you.